I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So we are looking at ionic equilibria. Now, before us are the lesson objectives. We'll be looking at, acid and bases based on Bronsted-Lowry. That candidates should be able to define acid and define bases both based on Bronsted-Lowry. Then we're going to look at, the terms conjugate acid and conjugate base. Yes. So candidates should be able to understand and use the terms conjugate acid and conjugate base. Then we're going to define conjugate acid base pair, identify such pairs in reaction, conjugate acid and conjugate bases in reactions. So please, I want us to listen attentively and get the best from today's lecture. So we are looking at acid and bases based on Bronsted-Lowry definition. Now, based on Bronsted-Lowry, a Bronsted-Lowry acid is a proton donor. So based on Bronsted-Lowry, an acid is a proton donor. A proton is a hydrogen ion, which is a proton, hydrogen ion positively charged. So this is a proton. A proton is a positively charged ion, which is hydrogen ion. So an acid is a proton donor. Any substance that is capable of donating hydrogen ion, donating a proton, is said to be what? An acid. Like if you look at this equation before us, this is the acid, this is the proton donor, this is the acid. It donates what? A proton to the base, to water, which is the base. So this is the acid, this is the Bronsted-Lowry acid. Why water is the Bronsted-Lowry base? Because it accepts a proton to form hydroxonium ion, while this one donates a proton to form chloride ion. So an acid is what? Is a proton donor. So hydrochloric acid is an acid because it donates a proton to water. So this means that the water acts as a Bronsted-Lowry base. So the water is accepting what? A proton. So you can look at this is the base and this is what? The acid. So based on Bronsted-Lowry, an acid is a proton donor, while a base is a proton what? Acceptor. So it's as simple as what? A, B, C. So we'll talk about Bronsted-Lowry definition of an acid and base. We define acid as a proton donor. Any substance that is capable of what? Donating a proton is an acid, while any substance that is capable of what? Accepting a proton is what? It's a base. So let's focus on Bronsted-Lowry base. A Bronsted-Lowry base is a proton acceptor. So any substance that is capable of accepting a proton is a Bronsted-Lowry base. This is a Bronsted-Lowry base. What we have here, ammonia is a Bronsted-Lowry base because it is capable of what? Accepting a proton. This is a Bronsted-Lowry base. It accepts a proton to form ammonium ion. While this is a Bronsted-Lowry acid, it donates a proton to form hydroxide ion. So ammonia is a base because it accepts a proton from water. This means that what? Water acts as a Bronsted-Lowry acid. So the water is donating what? A proton. So this is the Bronsted-Lowry base and this is the Bronsted-Lowry acid. Now there are certain substances that can act as either acid or bases. We call those substances amphoteric substance. Water is an example of what? An amphoteric substance. It's capable of acting as an acid and also capable of acting as a base. It can act as an acid, it can act as a base. It can accept a proton and it can also donate a proton. Such substances like water, if water reacts with an acid, it will act as a Bronsted-Lowry base. But when it reacts with a base, it will act as what? A Bronsted-Lowry acid. So substances like water, I will call them what? Amphoteric substance. So based on Bronsted-Lowry definition, an acid is a proton donor, while a base is what? A proton acceptor. And we have what we call amphoteric substance that can act as what? Bronsted-Lowry acid and also what? Bronsted-Lowry base. So they can act as Bronsted-Lowry acid and also as Bronsted-Lowry base. Now I want to look at the conjugate pair. Now a conjugate pair is a pair that occurs by a proton transfer when a reactant is linked to a product by the transfer of a proton, by the transfer of a hydrogen ion. We call it what? A conjugate pair. Now if a reactant is linked to a product by a proton transfer, by the transfer of hydrogen ion, we'll call this pair a conjugate what? A conjugate pair. We've discussed that an acid is a proton donor, while a base is what? A proton acceptor. Now if you look at what we have here, this is an acid. This is an acid, and this is a base. This is a base to accept the proton. This is an acid, which is the proton donor. This is a base to accept the proton. Now, if you look at the acid on the reactant here, it's linked to the product by a proton transfer, which is the base. So this is a conjugate pair. This hydrochloric acid and the chloride ion they are what? They are conjugate pair. That's what we call a conjugate pair. That the reactant is connected to a product by proton transfer. We call it what? A conjugate what pair. Now, if you look at the water here and hydroxonium ion, they are conjugate pair because they are linked to each other by what? A proton transfer, by the transfer of hydrogen ion. If this one transfers hydrogen ion, you get the what? The base, which is what? Water. So a conjugate pair is a conjugate pair occurs if a reactant is linked to a product by what? A proton transfer. So for an acid to behave as an acid, it must have a base present to accept the proton. So if you look at this is the acid, and this is the base to accept the proton. So this is the acid, and this is the conjugate base of this acid. This is the conjugate pair. This is the conjugate base. This is the acid, and this is the conjugate base. And this is the base, and this is the conjugate acid. And they are linked to each other by what? By proton transfer, by the transfer of hydrogen ion. This is the base, this is the base, and this is the what? The conjugate acid. They are linked to each other by proton transfer. And this is the acid, and this is what? The conjugate base. They are linked to each other by proton transfer. So an acid-base pair is what we call what? A conjugate pair. So it's as simple as what? A, B, C. So based on what we've discussed so far, these are questions for us to answer. Identify which reactants are acid and which are bases in the following reactions. So please, I want us to attempt these few questions, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So please attempt the questions and feel free to reach out to me. These are more questions for us to attempt. Identify the acid and the base on the right-hand side of this equilibria. So attempt the questions. B, identify the acid on the right-hand side of this equation, which is conjugate with the base on the left-hand side. So please, I want you to listen to the lecture attentively, and I believe strongly that you'll be able to answer these questions. So please attempt these questions. Feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much.